these are the same exact equations, okay? So r squared, which is 5 squared, which is 25, equals x squared plus 1 squared, which is 1. Move it over, 24. X squared is equal to 24. X is equal to the square root of 24. And then I simplify that radical. It's going to be 4 times 6. So it's going to be x equals 2 root 6. And don't forget, a lot of you are going to miss the plus or minus sign right there. And I forgot to put the plus or minus here. Did that on purpose so that you would know if you take the square root, you have to put plus or minus. Now we're going to finish it up. Which one is it? It's in quadrant 2. Beta is in quadrant 2, which means the x value is going to be negative. Because of this negative right there, I'm going to cancel those out. Okay, so it's going to be negative 2 radical 6. I'm going to use a different pen if I have one. A nicer pen. I had a nicer pen around here somewhere. Never mind. So I found the sign. Of course, the reciprocal of the sign is the cosecant of the angle is equal to reciprocal of 1 over 5 is just 5. And then I had to find the cosine of the angle. It's equal to x over r, the adjacent over hypotenuse. Adjacent is negative 2 root 6 over radius, which is 5. The secant of the angle is equal to flip of that. It's the secant, cosine, cosine right there. It's 5 over 2 radical 6 negative. Your teacher makes you rationalize the denominator. It's multiplied by root 6 to top and bottom. The tangent of the angle is equal to y over x, opposite of adjacent, y over negative 2 root 6, which is 1 over 2 root 6 with the negative in front. I hope you can see that. And the cotangent of the angle is equal to, flip of that is 2 root 6 over 1 negative. We don't have to put over 1. Next couple questions. 20, find the sine, cosine. Y equals negative 3x, and theta is in quadrant 4. So I have to find the value for which x is going to be, and x is going to be positive, y is going to be negative. So just plug into this equation when x equals 1, y equals negative 3, according to this equation. And is this in quadrant 4? Yes, it is. If I plug in x equals negative 1, then it will be in quadrant 2, right? Because the y value will be positive. Think about that a little bit before you actually start working on the problem. So this is going to give me a condition which I have to satisfy. That's your x, that's your y, and r squared is equal to x squared plus y squared. R squared is equal to 1 squared is 1 plus negative 3 squared is 9. R is equal to square root of 10. Don't forget, the radius is always positive. Okay. You want to find the sine of that angle. Now, sine of that angle is going to be y over r, negative 3 over radical 10. The cosine of that angle is going to be x over r, 1 over root 10. Okay. Most of these problems are going to be pretty easy as long as you know what you're supposed to be doing. Practice makes better, guys. So I would do all the odd, even ones again, and then you should be able to do most of the odd ones. 22. If the secant of theta is equal to negative 2, what is the cosine of the angle? Well, we know they're reciprocal functions, so therefore, just if you're not sure how to reciprocate that, just put it over 1 right there, and then just flip it. The cosine of the angle is equal to negative 1/2. Well, there it is. They want you to distribute this out. You have to use FOIL on this. So F first is sine times sine is sine squared of theta. And you should have this notation by now. That means sine of theta quantity squared. Minus 4 sine of theta. Minus 4 sine of theta. And then plus 4 sine of theta. And then plus 4 minus 4. You have to multiply it. minus 16. These cancel, you get sine square root of theta minus 16. A little bit of hint, next year you're going to be doing lots and lots of distribution and factoring. These factors have a very, very special name. They're called conjugates. And for most of my students, they already know what the conjugates stand for. One is a plus, one is a minus. That gives you a hint. Another hint would be Spanish. We know that this expression right here, when you distribute this out, it becomes sine squared minus 16. Sine squared of theta minus 16, that is. And we know that this expression is called the difference of squares. Some teachers call it difference of two squares. But this is a very special expression. These are very special factors. Going to be going over these like crazy next year again. Secant theta equals 2. Given quadrant theta is in quadrant 4, find the cosine, sine, and the tangent. So let's rewrite this. Secant theta is equal to 2 over 1. I know that the cosine is x over r, so the secant is that's equal to your radius, that's equal to 1. So x squared plus y squared is equal to r squared. X squared that's x right there, sorry. I don't know if you can see that or not. R over x, so x squared is 1 plus y squared is equal to 2 squared, which is 4. And so solving for y squared is equal to 3. I subtracted 1 to both sides. Y is equal to square root of 3 plus or minus again. Now, since the angle theta is in quadrant 4, if you look at quadrant 4, there it is, right there, quadrant 4, and you know that my x is going to be positive, my y value is going to be negative. There it is. Okay. Now I want you to find the cosine of the angle. Of course, it's going to be the flip of that, or it's just going to be x over r, which is 1/2. What's the sine of theta? Sine of that angle is going to be y over r. Y is negative root 3 over r. What's the radius? Was 2. And the tangent of the angle is going to be y over x. Where's y? Where's my y? Y, yes, over x, which is 1, negative radical 3. By the way, this is approximately negative 0.866 root 3. I know that pretty well. That's going to be negative 1.732050808 because I don't have any computer calculator on me that has something like that. I memorized that. 26. 28. Simplify this expression. 1 over cosine of theta minus, I'm going to put this over 1, and what I'm going to do here at this stage is find the common denominator. So I'm going to multiply by cosine over cosine. So that becomes cosine squared of theta over cosine of theta. If you cancel out cosine theta, we'll just end up with cosine theta, but I want to make it into one, these two terms into one single fraction, okay? So that becomes 1 minus cosine squared of theta. Combining them over cosine theta, we keep the denominator. This is very, very important. You should figure out what that is. We know that sine squared plus cosine squared equals 1. 1 minus cosine squared is equal to sine squared. So it becomes sine squared of theta over cosine of theta. There you have it. Number 30. Show that the cotangent of the angle plus the tangent of the angle is equal to the cosecant of the angle times the secant of the angle. The cotangent of the angle is going to be, can you wait a second please? Give me about 10 seconds or 15 seconds. Sorry about that, guys. One of my students came, so I have to wrap it up as fast as possible. So the cotangent of the angle is going to be the cosine of the angle over the sine of the angle. So what I'm going to do is I'm going to manipulate this side to this side, and I'm going to use a cheat method just a little bit and uncheat myself. So here, the cosecant is 1 over sine of theta times 1 over cosine of theta. So if I can get the left side to look like the right side just a little bit, and then I can uncheat and make sure that it looks like cosecant times secant. So cosine theta plus sine theta over sine theta plus tangent of theta, which is sine of theta. You should have this by now. These are reciprocal functions of each other. Cosine of the angle. Now we have to have common denominator. So I'm going to multiply the common denominator is cosine times sine. So I'm going to multiply this by cosine times cosine. Multiply second term by the sine, numerator and denominator. And let's see what happens. Cosine times cosine is cosine squared of theta plus sine times sine is sine squared of theta, and over one single denominator, which is cosine of theta times the sine of theta. And cosine squared times sine squared, that's equal to 1 right there. You know that's a Pythagorean theorem in trigonometric form. I'm going to finish this up right over here, just a little bit. So it's going to be 1 over cosine of theta times the sine of theta. And we know that we're trying to get to here, look like this, so we just separate them. That's the same thing as 1 over cosine of theta times 1 over sine of theta. Right? If I go 1 times 1 is 1, cosine times sine is cosine of theta times sine of theta. We know that 1 over cosine of theta, that's called the secant of theta, times 1 over sine of theta, which is cosecant of theta. Last question. 26 minutes, I got about a minute left. I want to show that that's equal to 1 over cosine. I'm going to do this really fast. Sine of theta times 1 over, cosecant is 1 over sine of theta, plus cotangent of theta is going to be cosine of theta over sine of theta. I'm going to distribute this out. Sine of theta over sine of theta is 1 plus sine of theta plus times cosine theta over sine theta. The sine theta will cancel. You end it with cosine of theta. Check. Since this is the hard side, I have about a minute left. So since this is the hard side, I want to simplify it to the simple side. Notice how I changed all of the tangent, cotangent, secant, cosecant into the sines and cosines. And then I'm just going to distribute that out. We know that sine of theta times 1 over sine theta is obviously 1. I can multiply it out. These cancel, or you could have sine of theta times cosine of theta. If you're kind of like wondering what's going on, you can just put it over 1. That way you can just distribute this out. And hopefully that's enough to get you started on your chapter test. Good luck. Thanks, guys.